Hi, this is Assistant Professor Karen Browse with UMass Amherst, and I'm going to be introducing setting up Rhino models for using Rhinocam and our CNC router. The first thing I'm going to talk about is really how to set up your files, and while in particular I'm going to talk about the sequence that we're doing in Analysis and Representation 2, really this sequence will also work for anybody trying to learn how to use Rhinocam in our router. In particular for this project, we're going to be starting with using foam, and it's much easier as a practice project for us to work with materials that are only 2 foot wide rather than 4 foot wide, although our router can handle 4 foot wide materials. So I'm just starting by setting up a template here, and the template assumes that you have a 2 foot wide piece of material, which is how we've purchased the foam. It does have a tongue and groove edge, so we're going to move your model in 2 inches, and in this case for this model we're just going to work with the 16-inch square that we're going to offset 4 inches from all the edges just to give us enough clearance in case we keep working with these files and we want to start flipping over the materials and milling the backside. For this first assignment we're just going to work with the top side, but I would like everybody to set up a template that looks like this. Once you have that set up, you can set up a piece of stock around it, the foam that's going to go around your surface that you're going to be working with, so you can just extrude that. And then you're going to start generating surface. So we've already done this as part of our first week's exercise. We've generated some surfaces, so everybody has a surface that they're working with. In particular, I'm just going to start showing this one, which is a height field. It's not one of the ones I milled for this class, but I want to show you because I want to show you a little bit about steep surfaces first. So before you even are getting to use Rhinocam, a couple things I would recommend. The first is you can see if I zoom out that I've really cleaned out the rest of my file. So in class we really emphasize an iterative process and developing a lot of different things that you're working with. But when you're coming down to milling your piece, it's really much better to just clean out your file, get rid of any extraneous materials, and just work starting at the 0, 0 axis here. So for our purposes, it's much easier when we're aggregating files to put in a lot of files all at once if everybody works from the same origin point. So for us, we'd really like the origin of your model to be at the top of your model at the 0, 0, 0 point. So you can see that right here. It's actually at the top. The second thing is that you're going to want to work with a stock here that I've made. So you've extruded this to be 24 by 24 by 2 inches in the negative Z direction, and then your actual surface will be 16 by 16 in the middle. So first let me just show you one thing, which is the main thing about using our router. We have a 3-axis router, is that you cannot have any undercuts in the router, in your model. So one way to do that is to analyze your surface by going in here and saying draft angle analysis. You're going to click on your surface and then enter. And over here you can see the spectrum that we're looking for. So blue would be pretty shallow, and in this case red would be very steep. So we have, we'll turn off this so we can look a little closer. We don't have a lot of reddish orange even in this model. We have a couple of more vertical surfaces in here, but I think it's going to be okay. One way to really check and make sure you have no undercuts is to set it from 0 to 180. And so at this point 180 means everything's okay, and the blue means everything's okay, and the red would mean that you wouldn't be able to cut it. So it looks like we're okay here. If you'd like to save this for any reason at all, a way that you can do that is by asking it to extract the analysis mesh. So basically what just happened when we did that is we made a mesh, and it's a rendered mesh. So we do that, and now we're going to select this mesh, right? So now we've extracted the mesh. You can see the mesh is overlaying, and as long as we keep this little draft angle box on there, we have the mesh. You see we can adjust the mesh. But if you want to keep this separate from your surface for any reason, you can pick it. Looks like I'm picking my surface, but for now let's just clear them from each other. There we go. Oops, looks like I took my surface with me. Okay, so now I'm just going to move the surface just to show you, and then we're going to actually move on to another file. Okay, so here, if I turn this off now I have the meshes here and I have the surfaces here. And if you're not sure what's what, then you can click on here and you'll see this is a mesh and this is your surface. So in this case, if I want to keep it, I turn this off, and then you can see if I go into rendered that my regular surface is just rendered plain, and then the analysis mesh retain the colors. So if you want to keep that just as a reference, so if as you're changing your surfaces, you're keeping track of what you're doing, you're welcome to do that. Okay, so for now, actually what I'm going to do is go into a different file that I was working with. So we're going to save that. All right, so here's the surface that I went and milled for this class. So just to go back to the layering system, so you have your template that you're going to set up to get started. Oh, looks like I erased it, but I did. Before I did that, I made my stock, and then I made a surface. Okay, so most of you are going to be working on Rhinocam in our lab in FAC 444, and just something that you're going to need to know about in there is that because it's a group lab, there's a few things that you need to know to learn Rhinocam, to load it. So this is actually on our course blog, and Rhinocam is a plugin for Rhino, but it's our CAM interface. You can see it looks like this, and normally when it's loaded, you would have this tab up here. And so you can click on it and you get this machining operations menu over here. If you're in the lab and you pull up Rhino, you've probably noticed after the last bit of the semester that it gives you a question about whether you want to load the software. And if it doesn't, then what you want to do, pull up this document and you're going to go to Plugin Manager, which is going to give you this long list. You're going to scroll down, and then if you don't see Rhinocam, you're going to say ask to load disabled plugins. And then when you close Rhino and reopen it, you're going to get this dialog box, and you want to click yes to run Rhinocam. We do have 5 licenses, so but we have more than 5 people in the class. So if you're just in there with 5 people, you could probably just go in, might already be retained, and you don't have to repeat these steps. If there are already 5 people working in Rhinocam, you can load Rhinocam and you can work, but you can't save your settings. So it's fine to go play around, but if you're going to want to save your settings and post your files, then the way that we have it organized is that as soon as one person leaves the key server, then the next person can log in. But you do need to check in with people and make sure that you can get your timing to work out so that you can log in before you lose your work. And the last thing I want to mention, a little troubleshooting thing, sometimes the machines in the FAC kick off of the internet, and you will need to have internet access to connect to the key server. So if for some reason you're having difficulties, the first thing I would say is to go down and troubleshoot your internet access and make sure that you're connected, and if not, you need to reconnect to the internet in order to load. So I'll go through a few more setup items and then we'll start generating toolpaths. So the first thing that you're going to want to do is check your machine setup. And mostly we should have these preset for you, but you do want to check that it's set to a 3-axis machine. So you just check this, but it's probably fine. And the second thing is that you're posting to the Techno ISIL. That's our setup for our machine. So you can go in here. It should say it already, the current post processor, but if for some reason it doesn't, you just want to check this and make sure that you're okay. And then the posted file extension for our machine is an NC file, so that's what you're going to be working with. both of those should be fine. So the next thing that you're going to want to do is set your stock. So you're going to create, generally for at least this first exercise and for much of our work this semester, you're going to check a box stock, which is just a regular box. And you can usually, in something rectangular, we're just going to copy the model bounding box, and then we're going to say OK. So in the case of checking, what you can do is we have some simulation options in here, and you can go in, click on Simulation Preferences, and there's a few choices that you might want to make right off the bat. So a voxel model is going to run a little bit faster. It's going to be less complicated. A polygonal model is going to give you a finer resolution. So I had this set for polygonal the other day, but if you're finding that you're slowing down, you can easily just change over to the voxel model. The other thing that you want to pay attention to is the transparency. I like to keep it at a little bit transparent on this end of the spectrum so that it's not bothering me when I'm looking at it, but I can still see where it is. And then we want to keep your tool display to solid, display tool holder during simulation, and then we're just going to say OK. So when there's basically two tabs, the Program tab for setting up your machining operations, and the Simulate tab, which is when you're simulating the operations. And down here, what's really important about this is just understanding, in terms of if something's disappearing on you, that there are these different tabs at the bottom depending whether you're in Program or in Simulate. So in Simulate, you can toggle on and off the actual model. You can toggle on and off the stock to see where that's sitting. You can toggle material texture. Here it's just preset to some sort of wood. The tool path, which we don't have any yet, and then we'll get into that a little bit later. So my main point is that they do look different in the different tabs. So if you're in one or the other and you're confused about why things are working a certain way, just look down at the little buttons down here. So here we can toggle the stock visibility, right? So if we turn off the stock that I have in my model, we can see how this is sitting relative to the foam stock that we're going to be using. There's that material texture. We're going to keep that off. The tool paths that we're going to generate. These are the main things that we're going to do. Okay, that's going to conclude our setup video, and then the next thing we're going to do is go through tool path generation. Thanks.